This video is going to demonstrate the cubed root of some numbers. We're going to have fractions as well as variable expressions. The first thing I want to do is describe the rule when we're talking about cubed roots. The cubed root of a real number a is written as the cubed root of a using this notation, and the cubed root of a equals b only if b cubed equals a. So as we look at this, we can refer back to our understanding of what the square root is. So when we look at the square root of 25, we know that the logic behind getting this answer is what times what equals 25. Now we understand that this index is 2, so we're looking for two things that multiply to get 25. So we know that it's 25 times 5. So the square root of 25 is 5. Now there's a list of numbers that we should know. They're called perfect squares. And they're found simply by squaring each of the counting numbers. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and this goes on forever. Now there's a second list that's also really important for us, is the perfect cubes, because now we're dealing with cube roots. So how would we find those numbers? So the perfect cubes are 1 cube, which equals 1, 2 cubed, which is 8, 2 times 2 times 2, 3 cubed, which is 27, 3 times 3 times 3, 4 cubed is 64, 5 cubed is 125, and these are some numbers you should memorize, just like the perfect squares that you should have at the tip of your fingers. So if we use the same logic that we used with this question, with this cubed root, in essence, we're trying to find three numbers that multiply together to equal 8 over 27. Now, any fraction we can divide into a numerator and denominator. So if we look at the numerator for the moment, what three numbers multiply to get 8? Well, we determined that 2 cubed is that. So if we're looking at a fraction, we could have 2 as our numerator. And what three numbers that are the same multiply together to get 27? So we said that 3 cubed is 27. So based on this logic of cubed root of what three numbers that are the same multiply together to equal this term, there we have 2/3. Now there's a second way that we can look at this cubed root. Any cubed root that's a fraction, as well as square root, can be broken up into 2 cubed roots and dealt with individually. And again, if we use the same logic as we had up here, what three numbers multiply together to get 8? So the cubed root of that is 2, and the cubed root of 27 is 3. Now, another question we have, if we include a variable term, and we want to find the cube root of this, again, the same logic we can apply. Essentially what we're looking for, if we look at the 64 component first, we're trying to find three numbers that multiply together to get 64. Well, from our perfect cube list, we see that 4 cubed equals 64. Now we want a negative. And earlier I had mentioned that all of these have to be the same number. So when we say the same number, if we have an odd number of negative signs, that equals a negative. So that's beautiful for us, because negative 4 times negative 4 is a positive 16, times a negative is negative, and then 64. Beautiful. So the first component of this is negative 4. Now we're looking at the cubed root of y to the 6th. Again, same logic. What times itself 3 times is going to equal y to the 6th? Well, we know that the base is going to have to be y. Now, what are the exponents here? Now, we know from earlier chapters that when we have the same base, we add the exponents. So, in essence, we're looking for what plus what equals 6. and that's going to be 2. And again, we could look at y squared times y squared is y to the 4th, times another y squared is y to the 6th. So when we look at the cubed root, what times itself 3 times equals y to the 6th? That's going to be y squared. And again, as we had done with this example, we could have broken this up. As I said, we have this multiplication with a cubed root or even a square root, and we can break it up into 2 separate items and work with them individually. So we could have this product as a product of 2 separate radicals. And as we just did up here, I'm not going to do the whole work again, but you can see that this is going to be equivalent to -4. This is going to be equivalent to y squared. Therefore, the cubed root of -64y to the 6th is -4y squared. Bam.